Hello everyone, we are going to do a Montecarlo simulation by using this case study. So let's read. Madeira Manufacturing Company. The management of Madeira Manufacturing Company is considering launching a new product into the market. The fixed cost to initiate production is $30,000. The variable cost of the production is uniformly distributed between $16 and $24 per unit. The product will be sold for $50 per unit. The expected demand for the product is determined to follow a normal probability distribution described by a mean of 1,200 units and a standard deviation of 300 units. Develop a simulation using an Excel worksheet conducting 1,000 trials to answer the following questions. What is the average profit of the simulation? What is the probability that the project results in a loss? What is your recommendation regarding the market introduction of the product? I have prepared a worksheet model for this case. Here it is. The important thing is to calculate the profit. Okay? In order to calculate the profit, we need to know the variable cost and the demand. Those two variables are random variables. We don't know what number or what result we will have in those variables. But we know that the variable cost, this random variable, follows a uniform distribution and varies between 16 and 24. On the other hand, the demand also is a random variable that follows this time a normal distribution with mean 1,200 and standard deviation 300. With those data, we can generate random numbers that follow those distributions and then calculate the profit. So imagine that we are generating a variable cost for one day, a demand for the same day, and then we can generate the profit of that day. That will be the first step. Okay, so first we're going to generate the random number for the variable cost. We know that's a uniform distribution between 16 and 24. How do we generate a random number with a uniform distribution? Well, we can use this formula. Upper limit minus lower limit times random plus lower limit. What this formula means? Well, random is with the function random, you generate a number between 0 and 1 with uniform distribution. If you multiply it by the upper limit minus the lower limit, that's the length of the interval you are generating, you're going to enlarge that random number from 0 to 1 to the length of the interval you are going to generate. In this case, the length is 8, so if you multiply by random, you are generating a random number between 0 and 8. And to finish, in order to translate this interval to start in 16 and to end in 24, we add the lower limit. We are translating that interval from 0 to 8 to 16 up to 24. So let's put this formula here. Low upper limit minus lower limit times random. We close the parentheses and we add the lower limit. And as you can see, we have a number between 16 and 24. If we generate it many times with Fn F9 in my keyboard, in this case, you can see that we are generating different numbers, but always between 16 and 24. Okay, let's generate the demand. The demand follows a normal distribution. In this case, since it's a different distribution we are going to generate, we have a different command to put in the Excel. In this case, it's normal inverse. And you follow the help that Excel gives you. First, the probability. Probability is a number between 0 and 1. Oh, I can put random then. Random is a number between 0 and 1. Then is the mean of the distribution, 1200. Then the standard deviation, 300, and you close. There is a technical stuff here. The demand must be an integer number. No, you cannot expect a demand of 3050.53. What does mean does 0.53? So you can round up or round only. Round to 0 decimals. In that way you generate an integer demand. So how you calculate the profit? Well, first you must know the profit per unit. How much is the profit per unit? Well, is price per unit minus variable cost per unit. So let's put profit equal price per unit minus variable cost per unit times, that's the profit per unit. How many we sell? We sell the demand. And I don't have much space. Let me enlarge this Excel sheet. Now we have to subtract the fixed cost minus fixed cost. So you have there the formula for the profit. So let's put it. First, the profit per unit times the demand minus the fixed cost. And here is the profit for one simulation. Let's simulate it many times. Look, we can have negative profit, a loss. Why is that? When the demand is too low, so low that the fixed cost is bigger than this multiplication, then we have a loss. For example, you have a demand of 0, you have a profit or a loss, in fact, of $30,000, right? Only the fixed cost. Okay, we have simulated one profit, but one profit is not enough to tell you the whole picture. We have to simulate it many times, and we use the law of big numbers in order to have so that this many times of simulation, this 1,000 times of simulation in this case, has a meaning. So we are going to simulate this profit many times. And as you know, every time I press enter, this number, the profit changes because Excel isn't redoing the simulation. So let's simulate this number many times. First, we select the whole table. We go to data, what if analysis, data table. We select a column input cell. I always like to select B1. Select an empty cell, okay? I have the B1 cell empty. You could select any empty cell. For example, D2, E2, any empty cell. In my case, I like to select B1. When you do it, you generate 1,000 profits, like you are simulating 1,000 trials. So we have here 1,000 trials. This is like a coin. When you toss one time, when you do one simulation, when you toss a coin one time, you don't know what you will have, head or tails. But when you toss many times the coin, the relative frequency of seeing heads approximates 50%. It's the same idea here with the law of big numbers. So let's work with, here is in Spanish, so let's put it in English very fast. The standard deviation, minimum, maximum, and here profit, right? Okay. So let's start doing this. Mean, well, the average to get the mean of the profits. Remember, we are going to study the profits, the 1,000 profits. We're going to do descriptive statistics of these 1,000 numbers. So the first thing, the average. Then the standard deviation. I always forget this formula. Oh, here it is. Standard deviation of the sample. Then the minimum of those profits. Then the maximum. This number describes all this list of profits. Okay, for example, we know that the average is around $6,000. So in average, we get $6,000 of profit. But this profit has a lot of variation, of dispersion. That's what the standard deviation gives us. The minimum, that's the worst case scenario of these 1,000 simulations, is a very big loss. And the maximum is a very big profit. So we could calculate also what's the chance of having a loss. Okay, what's the probability of having the loss? In fact, we are giving an approximation, right? We're using the law of big numbers, where we are approximating the probability of this loss by the relative frequency of a loss of the 1,000 profits. So let's use this. So we have to count how many losses we have of these 1,000 profits. So we have to use a count conditional, count if, of all the profits. Let's go to the command, and we have to give the criterion less than 0. You could give other numbers, and then we divide it by 1,000 because we are calculating the relative frequency, and we have 0.263. So we have done A, B, and what's your recommendation about regarding the market introduction of the product? Well, I am a very conservative person. I don't like risk much, and for me, having a probability of a loss of 0.26 is way high. So I will not introduce this product into the market. Maybe I can get a nicer probability here. How? If I could reduce, for example, the variable cost, instead of running from 16 to 24, imagine from 14 to 22, the probability of loss improves to 0.20. Let's try with 12 and 20. Now it's way better, to 0.14. Of course, we have to see if we could reduce that variable cost from initially 16 to 24 up to 10 to 18. 12 to 20, sorry, to 12 to 20, right? Or to 12 to 18 is way better. We could play with this simulation and see another other type of changes. For example, what happens if the demand increases or decreases, things like that. Okay, hopefully you liked this video, and see you again.